Hi guys, I'm back with another tutorial on video gaming for the Atari home computer if you're interested. This one was developed a couple of years ago. It's just a simple game. It doesn't really have a whole point to it yet, and I kind of never really finished it, but it's basically kind of like a dungeon type game. I was going to try to make it into, you collect objects and stuff like that, and you have doors to open, but I never really could keep them interested in it. But this is just controlling a little man that's moving on the screen here. You probably seen my earlier video maybe already that shows the dot on the screen that's trying to enter the cage. It's basically a mousetrap. This one takes a step up on the Atari and it allows you to change the characters that you're seeing here on the screen and basically create them to whatever you want them to look like. In this case, I just set up kind of like a building kind of look, and there's a man here, and he kind of does all kinds of stuff. He shoots buttons and shoots little bullets and kind of stuff like that. So he kind of moves around here, and he gets stuck if I drop him down here. I haven't finished this part, but this is kind of where I'm setting the game at. Oops, I just got an error message on that one. Let me rerun this. I didn't check for some of the out of bounds when I'm shooting, so what happened is when he got down to the bottom there, down here, there was nowhere else to go over here, so the bullet was basically traveling off the screen. So you can see that when I go over this way, though, as a man hits the wall, it instantly takes him to a new screen. So it's a different screen from what you saw earlier. So you can kind of set up your own screens this way if you're interested in, basic video game programming. This is kind of the gist of, where to go with all that. And this is it's just pretty simple. He's just moving around from screen to screen. Fortunately, I haven't made him ascend ladders. I think he can ascend this one by pressing the button. Yeah, he gets up it that way. I think he gets stuck though. And then he kind of can jump a little bit too if you move him up and down. So if I go here, he kind of falls off. So this is that's a very basic program. I haven't really done anything else to it. I'll kind of go over the code for those who are interested in that, because I notice a lot of people have been watching my videos and they're always commenting about the code and stuff. So let's probably get into the good stuff, I guess you could call it. Okay. I called this one Game Starter because I really haven't come up with a name for the game yet. So I figured that was probably the best way to start this one off. See, this was developed back in 2007. Okay, so these are known as, dim stands for dimension. It means to dimension a string, and this is what this is, a string. It's going to dimension a string called M up to 100 bytes. Basically, it's going to store 100 locations and places I can use to store an M string. And then next it's going to have a string called CH string. That's just basically for character, and I set that for 100. I have R string, and I set this one for 13. I have G string also at 100 here. So this is how you set up strings whenever you want to display messages and stuff like that. Okay, so the next part here, for those who may not familiar with Atari Basic, is called go sub. So basically a go sub will go to this line 2902. Let me go down to that line. Kind of a pretty big program. 2902 was it, right? There's a mazes. I think it's gonna what it's gonna do, it's gonna go to this line right here, 2902, and this is gonna set up the Atari character set for graphics too. So basically what we're doing here is first of all we're going to restore 2904. So basically this is going to allow the data to be updated constantly. If you don't use the restore, sometimes you'll get error messages, so I always use the restore. The next line, 2903, says for I equals 1 to 32. This is basically incrementing from 1 all the way up to 32 with the variable of I. It's going to read A. You can call this anything you want. Just keep track of which variable you're using. And then it's going to take the character, remember we set up earlier in a dimension, and store I inside here. So it's going to store locations 1 to 32 inside of a string, and it's actually going to point this at a character set. So basically CHR string CHA is basically pointing this at the data. So what this is doing, read A, is actually reading each of these lines. So every time it says read A, like if I is equal to 1 and it says read A, it's going to have 104 in it. And the next thing it's going to do, let me see if that's right, 2904, yeah, that's right, 104. The next thing it's going to do it'll increment through this loop and it'll go to 2. So I will now be 2, because remember it goes up to 32. It'll be 2, and it's going to also have a 1 and 4, so we can kind of skip on that one. The next time is a probably better example. It's going to be 3, and now I is going to be equal to 133, so it's incrementing through, and it's pointing again where the I is setting it up, and putting everything into a string, and pointing it at the next data. So basically it's taking all these numbers you see right here and sticking them inside this string that can be read and used as a character set. So keep that in mind. So when this is all done, all these numbers will be stored in here one by one. So if you hit CHR1, it's going to be 104, CHR2, CHR3, CHR4, and so on. Okay, so what it does is it reads all that in, and down here at 2906, we'll skip down here because this is what it's done. Once it's done with the I, it'll skip down below the data to the next point. It's going to poke 106. This is just basically setting up a memory and moving it so that there's room for the character set. So it's poking 106, comma, peak 106, minus 5, so it's setting it back 5, I think that's locations, I don't remember. But it's use this whenever you're using character sets to point where you want the character set to find out or show up in memory, basically. And then it's going to set graphics 0. This is graphics 0, by the way. And then next it says, I set up a variable called begin equals peak 106 plus 1 times 256, and again this is that relocating the memory, and it's gonna, this one is interesting. The next one says poke 756 comma begin, and this slash means divided by, so divided by 256. So this right now is taking the character set that you normally see on the character on the screen here, like if you see each of these, like the 2, 4, and A, these are characters. And it's taking these and it's storing them into a character set that you can control and alter and change. So, as an example, if I go to graphics 1, use that one, and if I print to the screen, my name. Okay, so you see I kind of printed my name here to the screen. These are characters that later can be changed into stuff that I want them to look like. I could turn this E into a wall, or I could turn this into a person, basically by manipulating the bits inside of these characters. So let's go back to that line. Oops. People out usually like the scrolling of code too, so. Okay, so right here again, it's going to now take everything that was in this and store these into the character set. So basically it's creating characters. These are actually, I could probably set up another video for this, it'd be kind of long, but this is how you would create characters, and you have to set them up in a graph, and you actually plot out how you want the character to look, how you want him to look when he's drawn and basically stuff. Okay, and this one might kind of lose people, but this A equals USR address CHR string, comma 57344, comma begin. This is actually setting up machine language, and you know what? I told you earlier this was the character, but I was looking at this and I noticed that it doesn't look like a character set. The character set's actually down here. But what this is doing is this is actually setting up a fast way of reading the character set. If you don't do it this way, it'll take much longer for the program to run, and it's a little bit faster if you do it this way. So this is basically taking all of this and reading it into memory at this point at 57354, comma begin. So this is where the character set would start in memory, and the computer's gonna be able to read all this. This is a machine language program, by the way. If you ever see my machine language videos, it's converting this into an assembler program and basically compiling it into machine language so the system can see it and initialize the character set at a faster speed. Restore 29115. This is where I was trying to get. So this restore 29115, here's kind of the beginning of where the characters poke into memory. So earlier what you were seeing up here when I showed you that I equals 1, that was actually reading in the machine language that would be stored in here. If you remember the CH, that's where it's storing it at. Okay, and this USR is just executing it as a memory instruction to the, basically it's talking to the machine language and saying, okay, execute what you put into the computer's memory as a program. So the next thing here is, there's a remark there, is reading A. This is just basically going to go down here because remember 2915 is where we're starting at. So we're starting here. It's going to read A, and A is now going to be equal to 2. And then it's going to say if A is equal to -1, then return. Remember when it said go sub, I think it was 2902 or whatever earlier? Once this data somewhere down in here finds a -1, it'll return and go all the way back to the beginning. So basically we're going to exit out of this subroutine that we no longer need. But it's staying inside the loop right now because we want to be able to read all the data here into a character set. So here's how it does. It goes I equals 0 to 7. So this is taking the first 7 of these, and let me scroll this up a little bit. Hope I don't get it off the screen. I'm trying to keep it on the screen there. Let's see. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Oh, sorry. 0, 1, 2, 3, 4, 5, 6, 7. Trying to figure out where this extra 0 is coming from. I think this is probably reading the -1 or something. But what it's doing is it's taking all this data here, basically, and storing it into this location to begin, which I don't know if I showed you that earlier, but let me go back here. 29. Oops. I mean lowercase. Lowercase.
Ford leads the way in Arizona with more cars over 40 miles per gallon.
Excuse me, these videos just came on YouTube for some reason. Irritating. I'll shut them off there. So, give me 1 second. Let me figure out how to character back in uppercase. It's right here. Okay, so it's right here. So, got a little distraction from the mixer there. Oh, okay. You can't go. It's only 32,767 lines in BASIC. There's only 32,767 lines you can set up in BASIC. So, let's see. Where's that begin at? It might have been set up earlier in the program. I don't see it here anywhere. Let's go back to the program. See where I set that up at. Surprisingly, I know I didn't set it up there. So it goes to 2902. It's gotta be here somewhere. What if I skipped it here somewhere? Let's see. 756 coming in. Oh no, it was right here. That's right. So it's basically setting up the peak location for 106, and it's poking this into memory here. Where is that at? Right here. It's adding A to it, so it's basically adding whatever this number is that you just set in. As it reads, it's going to add 2 now to this memory found at 106. Multiply it by 8, which because there's 8 character bits when you're creating a character. And it's going to add each one from 0 to 7. So this is basically taking this data and storing it in a place where the computer can see it so it can change the character set later. And this is going to 2910. So this is looping back until it hits a -1. Let me go back down through this again. So it's basically going through all these characters line by line by line. When it gets down here to -1, it's going to be able to kick back out basically. So let me go back there. Whoops. Yeah, that's right. So once it's -1, it's going to return. So 2902 is now going to go back to the top of the program. We're going to leave off where we kind of started off at. I might have to shorten this one down. This is going to be like an hour in a way, so to explain all this. Okay, so this is setting up graphics mode 1. I showed you that earlier where I printed my name to the screen. And this is set in the location where you set that higher part in memory. You peeked into the higher part. These are just colors. This is just changing various colors of the screens to different settings that you want them for. So I have this one set for the wall. I can't remember, the one might be for the character or something like that, the man that moves on the screen. This one's remarked out, so I don't have this line doing anything. This is drawing the maze and stuff like that. So now when you see color 8 plus 160, it's actually going down to that data we had earlier and picking the character that's at 168. It's already been initialized. It's been changed into something, and it's going to plot that to the screen. I think that might be the character, but I'm not sure what that is yet. And this is just positioning messages. It's going to show your score. This number 6 is necessary when you want to output to graphics 1 and 2. And this is going to print the score on the screen. Right now it's just going to be 0 because SC hasn't changed here. DL equals peak 56 plus peak, this one is setting up something called a display list. A display list allows you to go ahead and change how the screen looks and how it displays information. And I could probably run that and show it to you. So I can do this step by step for people who can really follow what's going on here. Let me see if it even shows that. I think when I touch I can't see in the dark. Where did my joystick go? Okay. Got it right here. Okay, so if I go down here, let me just get off the screen again. I think when I touch this it might say it. Let's see. Well, I wanted to show you this, but I just ain't gonna work here. But what it's doing is it's actually controlling this down here, and it's going to allow this to change how it looks. And I wonder if I stopped it and see if it did anything. I don't know if you can see that. It's actually listed in the program. What it does is, I think it's actually up in here, because I had set it up here. So this is position, comma 0, number 6, text. We'll try something like that, see how that goes. There it goes. So basically, it just changed this screen. What it's doing is, I know what I remember it's doing now. It's shifting down the whole screen is what it actually did. Because originally this would start up here, so it's actually shifting down the screen is what it's actually doing. It can be used to display different kind of character sets, and you can set up different graphic ones there as well. But I think that's all I did with that one right here. And this is a little bit more advanced, so I won't go into a lot of explanation on this one. This one right here, TX equals peak 660. Since I haven't done this in a while, I'm gonna pull out my mapping book. This is the map in the Atari, and this shows all the locations in the book that you're seeing, like for this and this and stuff. So if I go to 660, because I can't seem to recall what it is. It's actually right here, so if you can see this one. And I can move it up a little bit more maybe. A little bit more. See it right there? Where it says, boy, I'm trying to hold this book up. It says address of the upper left corner of the text window. Split screen equivalent, locations 88, 89. So it's allowing you to set up your own text window mode kind of thing. You can basically recreate your own text window. You don't just have to have it down here. You can set them up here in the middle, wherever you want them. Once you learn how to use the display this interrupts pretty good. This is very similar to what we did up here earlier, where we was just initializing the characters. So this one's initializing a variable just called 10. This one again is going to go somewhere in the program to 1900. Let's go down to 1900 and see what that has to show. Okay, so 1900, we are restoring 2000, so we're going down here. So basically, I know what this is doing. It's drawing the maze. Position 0, 0 goes to 2000, goes down here and starts drawing everything. Right here's the whole maze. Y equals 1 is setting up the loop here from A to 20, reading everything in M. If it equals this character, then return back out. So it's looking through here until it finds this thing that looks like that to get out of the drawing. It means you're basically done drawing the maze and everything. And this is X equals 1 to 20, G string equals M string. This is just setting up different. What this is doing is actually drawing positions. When I go through the maze here, I'm manually drawing in different stuff into the maze, like the ladder and other stuff. So I think that was it. Let me see. Oh, actually, the ladder's already in here. It must be doing other stuff. But that's what these are the mazes, though, basically. So let me go back here to try to make this a little shorter for people. Not to bore them so much. Lots going on here. Setting up variables 6, x equals 6, y equals 5, px equals x, py equals y. So just keeping track of where your y is after you've moved it. Room, this stands for room, so room equals 1. This is the joystick, initialize the joystick, location 632. This initializing the trigger button on the joystick, which is the one on the side here. And this is keeping track, like I said, again, of your X and your Y. I don't know why I repeated that one, but I could take that one out. Just notice that. This is just setting up color, This is drawn. This is your character right here, X, comma, Y. This is initializing the joystick. I've showed this in previous videos. I won't go over this a whole lot, but this is setting up the trapping, and this is just a movement of the joystick, whichever position you're moving in. If you want to know more about that, just watch my earlier video on the simple game. Kind of cut that one down a little bit. Let's see here. Okay, X equals Y minus 3. I'm trying to see what this one does. So the joystick is equal to 14. I think this might be the jumping position. Yeah, it is, because Y equals Y minus 3 means the character, if you move the joystick up like this, it's going to make the character go up and down. You've seen him bouncing up and down. That's basically what that does. And BY lad, this means if you're by the ladder, then it's going to move him up and down. This allows him to ascend the ladder as he comes near it. So instead of making him walking up it, I could have done that in animation steps. I just made him jump it all the way up it. This is just a joystick. He's not by the ladder. Oh, I know what this means. If you're not near the ladder, then he's going to drop down, basically. So if I'm not near that ladder, when I walk the edge, he falls right off the edge. That's how you get him to fall off the edge. And this is just controlling, again, the Y location so that he doesn't go beyond the screen. Top part of the screen at location 3 there. Position 3. And then this is setting up the collision. He equals 170, and he's not by the ladder. Then it's going to let you know that you basically hit a wall. Remember, this is keeping track of X and Y, just where he was showing, what I probably had it up there earlier, where it was keeping track of where he was, so he doesn't pass through a wall or anything like that. These are other locations I have, probably setting up to capture other objects, I'm guessing. Like I said, if you need more explanation, maybe I can explain this later for people who really care about it. But this is just keeping track of different stuff that he's running into and doing different stuff like resetting the by ladder, or he's not by the ladder and stuff like that. This is 13, ST equals 13 in color 32. I think this is just erasing the movement or something. Y equals Y plus 2. That means Y equals Y means he's going down. I think this is when he walks off the... This is probably when he walks off the ledge and he falls off the ledge. That's what that means. Y equals Y plus 2. So he's basically going off the ledge there. X equals 18. So if he's at the bottom... Oh, I know what this means. This X equals 18 means as he's moving over here, you saw him earlier when he hit the edge here. 18 would be the location here. Then he's going to switch into another room. That's when you see me change to room. So I just basically incremented the room, and I'm using that to check for change in the room. And this is probably going to draw the new room, I'm guessing, there, without going there. Okay, and this one is saying if he's less than, so if he's way over here, then basically you've already gone back into the same room you came out of earlier, so it's just going to draw that room. Same thing here. Room's less than 1, it stays at 1, doesn't go anywhere. C2 equals 32. Not sure what that is, and not safe. This is probably just some of the game mechanics I was building in. Go to 130. This is just keeping them inside the loop. So basically, so it's very simple in general. I didn't want to bore people too much by, you know, going into a lot of explanation, but there's different stuff like you take the object into possession, so when you find an object, it's going to just draw a message and stuff like that. Here's where he starts shooting. So basically up here earlier, if you're pressing the trigger button, 644 location, this is going to just draw the bullets going in whichever direction that you're pushing in. Or you're pushing the direction this way, obviously to the left is going to make the bullet go to the left or to the right based on wherever you're moving the joystick. So this is just trapping it right here, keeping track of color CC equals 170. I think that's, yeah, this is if it hits the wall, the bullet hits the wall, then don't make it pass through it. Make it just stop right there. So, color 13, plot 8, comma Y. This equals 1 to 10 next S. Trying to see what this one does. I haven't looked at this program in ages, so. A, comma Y. I think this is just still, this is probably just drawing the bullets, basically. Drawing and erasing the bullets. And down here I got, oh, I see shoot right, shoot left, so this is right, and this is his left position, firing in the left position. This is how you set it up. You actually have to go backward if you use step -1 inside of a loop like this, a for loop. It'll do the reverse and move it in the opposite direction. So this is kind of just doing the reverse of that, basically. And it's pretty simple. There's maze 1, find the characters, we saw that earlier. And there's maze 2. So, I don't know what this is doing. I think there's one, the length in strings. It's taking whatever is in the length, so however long in string is, storing it into a variable of G, and keeping track of each of those individual characters. I'm guessing it's keeping track of this maze here. If it equals 32, I equals I plus 1. I don't even know if this is even being used, but that's kind of the basics of how to get understand how you could design a simple little basic program or basic game like that. People were interested in that, so. Okay. One other thing I wanted to show you, actually, before I go here, is remember earlier when I was talking about the 756, that's the characters you're seeing here on the screens here, and it's allowing them to change. So I'm going to save that location and I'm going to change it back in just a minute and show you how that works. Okay. So basically I took whatever was in 756 and I stored it into a variable called A, so I can remember when I change it back and revert it back. I'll show you in a minute. So now I turned off the character set, and notice everything suddenly changed because these stars, this plus, was a character before I changed it in memory to what I wanted it to look like. So this plus sign, or let's use the exclamation mark. The exclamation mark I changed into a ladder based on the code that was being read into those data statements earlier. So it just basically changes that bit by bit by bit from each direction of 8 by 8. So. And I don't remember what this one was. This might just be the character itself. Let me revert this back and I'll see. Yeah, this was basically your man. So that's basically what you're looking at, and how the Atari computer can manipulate and change the character sets and to make them look like whatever. You can change them to anything. I've done some pretty long games and had it doing. I had a shopping cart game one time. I had some kind of I don't remember, some kind of a weird ball game or something, but you can change them into anything you want them to look like. And when you get real fancy later, you can actually change these graphics here. You might have seen this in my machine language game. You can change the individual areas where they're striking here, and change the colors as they're going through. In like I think it's in a vertical blank interrupt, if I remember. A display list interrupt is what it's called. So you got display list. And you got display list interrupt. So that's basically what that's allowing you to do, is change them real time. So how long did this video go on? It tells me. That's actually the thing to tell me. But anyways, that's kind of to get you a start on that. So hopefully I get some views on these. If not, then I'm probably just gonna abandon this one again. And I just don't get a lot of following on it, so I don't really. Can't keep my interest if I can't keep an audience. You know, this is kind of how I am in general. So I just thought I would share the stuff with you. If you're interested, you can go ahead and subscribe to my videos. I have Atari, ASP.net. The big one is Grand Theft Auto modding, so people are really, a lot of kids are into that kind of stuff, and teenagers. So anyways, thank you. Thank you for watching.